Jensen Huang, the CEO of NVIDIA, did the kickoff at CES 2025, and I was there, and it was amazing. He dropped multiple announcements, and he talked a ton about agents, world models, autonomous driving, robots, pretty much every futuristic thing you can think of is getting powered by NVIDIA this year. Now, NVIDIA invited me to this event and they paid for a part of my trip, but they did not pay me to make this video. So let's watch it together and I'll give you my thoughts. All right, so first things first, his jacket was incredible, nice, shiny, and appropriate for Las Vegas.
Are you excited to be in Las Vegas? Do you like my jacket?
All right, so the first thing I want to talk about is this graph, which is really cool to look at. Only back in 2012, which was about 13 years ago, AlexNet was created, one of the creators, Ilya Sutskever, and basically it was a way of classifying images. And then fast forward, we have perception AI, generative AI, and then the key, bullish on agents, agentic AI. And that is where we are in 2025. And we're kind of already heading towards physical AI, but I believe 2025 is the year of agentic AI. So here he lists coding assistant, customer service, patient care, but it is so much more than that. It is the raw intelligence of a large language model wrapped with everything it needs to actually do things in the real world, whether it's the digital real world or the actual physical real world. So memory, tool usage, web browsing, access to your personal information, access to other documents. This truly is the year of agents. And I promise you're gonna get sick of me saying that very soon. All right, in the next part, he's going to talk about this transition from kind of classical computing as we've known it to this new AI-driven computing. And I actually believe that he's being conservative with his estimates. And when I talk to a lot of people, especially programmers, they think, well, it's going to be some combination of AI and traditional programming. But I actually think it's going to be more like that AI Doom demo, where every single frame of anything you're interacting with computers is essentially predicted by AI. And so you're going to have this predictive layer on top of the raw database. And that's it. I covered it in the video going over Microsoft CEO's predictions on the same thing. Agents are going to replace SaaS. It's all in the same vein. What is the point of an application layer if everything you need is generated on the fly based on data in a database? All right, next I'm going to show you a demo that he displayed during his keynote. And speaking of AI really taking over much of what we've known as computing to date, the majority of the scene is rendered using artificial intelligence. So they're doing full ray tracing, but only calculating the pixels in the traditional way 1 out of every few times. And so this is a completely new way to render video games. So here's the demo.
That was real-time computer graphics.
All right, so why was that so impressive? Well, 9 out of 10 frames were rendered using artificial intelligence in real time. That is what's so impressive. So only 10% of the frames were rendered using traditional ray tracing. Here's what Dr. Jim Fan, research scientist at NVIDIA, says about it. Y'all expecting RTX 5090, cool specs and stuff, but do you fully internalize what Jensen said about graphics? That new card uses neural nets to generate 90+% of the pixel in your games. Traditional ray tracing algorithms only render 10%, kind of a rough sketch, and then a generative model fills in the rest of the fine details in one forward pass in real time. AI is the new graphics, ladies and gentlemen. So really try to internalize how incredible that is. We are shifting quickly to video games being rendered or really generated in real time by artificial intelligence, predicted by artificial intelligence. And all we need is kind of a rough sketch of a scene, and then AI will fill in the rest. It's truly incredible. All right, so the first major thing that they announced at this keynote is RTX Blackwell and the 50 series of GPUs, which I think the most stunning part was the price point, but I'll show you that in a moment. Let me show you the demo video. It's not that long, but I found it to be really cool, so let's watch it. All right, so there it is. That is the most impressive thing. $549 for the equivalent of the top of the line 40 series GPU, 4090 GPU, equivalent performance coming in at 1/3 of the cost. Very impressive. All right, in this next section, he is going to talk about scaling laws and going from 1 pre-training to 3, which is pre-training, post-training, and in my opinion, most importantly, test time compute. That is the thinking models. So I found the entire part of this talk fascinating, so let's watch it in full right now.
Okay, so let's talk about AI. The industry is chasing and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has been observed and demonstrated by researchers and industry over several generations. And the scaling law says that the more data you have, the training data that you have, the larger model that you have, and the more compute that you apply to it, therefore, the more effective or the more capable your model will become.
So that's everything that we've seen essentially to date before really the more recent models that have come out. That is, the more data you throw at it, the better it will become. And there has been a race to gobble up as much of the public internet's data as possible, and even data behind auth walls and paywalls as well. And so this has been a race amongst all the top AI companies, but we're pretty much saturated on the amount of new data available.
And so the scaling law continues. What's really amazing is that now we're moving towards, of course, and the internet is producing about twice the amount of data every single year as it did last year. I think in the next couple of years, humanity will produce more data than all of humanity has ever produced since the beginning.
So that was an interesting statement, and I guess it's intuitive, but I hadn't really thought about it. I've talked about many times basically all of the data being saturated, but the amount of data being created is also pretty impressive. But as AI continues to scale up and is producing a lot of the data that we do see on the internet, then it's really just derivative data that we have to work with. So we train a model with our own human data, then that model is creating additional data that gets on the web. That additional derivative data is then used by the next model, and at that point, I don't quite know if it's going to be as high quality, but we'll see.
And so we're still producing a gigantic amount of data, and it's becoming multimodal. Video and images and sound, all of that data could be used to train the fundamental knowledge, the foundational knowledge of an AI. But there are, in fact, 2 other scaling laws that has now emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law. Post-training scaling law uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high-quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems.
Now, I never really considered fine-tuning and RLHF as scalable levers to greatly improve the quality of a model. Now, obviously they do, but I didn't really think it was on par with pre-training and test time compute. But Jensen definitely does.
And so it's essentially like having a mentor or having a coach give you feedback after you're done going to school. And so you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right.
And so that is very scalable. That is like AlphaGo, where it basically just plays hundreds, thousands, millions of games of Go until it becomes an absolute master at it, and even discovers strategies that humans haven't even thought of. That's the famous move 37 from the AlphaGo game against Lee Sedol.
And so an AI could be presented with a very complicated and a difficult problem that is verifiable functionally, and it has an answer that we understand, maybe proving a theorem, maybe solving a geometry problem. And so these problems would cause the AI to produce answers, and using reinforcement learning, it would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce.
All right, so that's the O1 model, the O3 model, any thinking model, Gemini 2.0 thinking. These models are incredible. These are the ones that are doing PhD level mathematics, beating humans at coding challenges, and just really impressive overall. These models chew up a lot of tokens. And that is why I'm sure Jensen is giddy every night that we have discovered that this is a very scalable way to improve the quality of models.
Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of a direct inference or one-shot answer, you might reason about it. You might break down the problem into multiple steps. You might generate multiple ideas and evaluate. Your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro. All of these systems are going through this journey step by step of pre-training to post-training to test time scaling.
All right, so next I just want to show this frame really quickly. This is the Grace Blackwell GPU. This is basically a bunch of Blackwell GPUs on a single motherboard, and this is what cloud GPU providers are using. And this is kind of what you rent from them if you do rent from them. So these are massive machines. I think he said it was 1.5 tons, and of course, very, very expensive. But one thing I wanted to point out is I'm reading this book called Chip Wars right now, and it's so interesting. By the way, highly recommended. And it talks about kind of the early days of Silicon Valley and how the first transistor was invented. And then even all the way back then, 50, 60, 70 years ago, they had this vision that transistors were going to essentially be in everything and change the world. And looking at it now, they were struggling to figure out how to put tens, hundreds, thousands, even then millions of transistors on a single chip. And now look at these stats. This one has 130 trillion transistors. That is just insane progress to think about. All right, let's keep going. All right, next, it's all about agents. And Jensen is, just like me, very bullish on agents. And I was so excited that he dedicated such a large portion of his keynote to agents. So let's hear what he has to say.
One of the most important things that's happening in the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. AI is a system of models. Some of it is understanding interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools. It might be using a calculator. And it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing, is going to go through the roof.
All right. And of course, when he says that, he's basically saying everybody's going to be buying more and more of our NVIDIA chips. Really, that's what he's saying throughout this entire presentation. It's kind of insane to think about. But here's the important parts. First, agents are coming. They're going to be flooding into the workforce in high numbers this year. That is my prediction. And then beyond that, we're going to have multiple different models working together. So we need the model orchestration layer, something like a Knot Diamond. I am an investor in them. We're going to need the agentic framework, Crew AI. I'm also an investor in them. And then all of these models are going to essentially go off, think, and then bring back the best result, exactly what you need. So actual, real-world, valuable tasks. Okay, next, I just want to touch on this briefly, but NVIDIA announced the Nematron series of models based on Llama that they are releasing. And it's essentially the Llama models, but tuned specifically for enterprise use cases. So we have a few. We have Nano, Super, and Ultra. Obviously, Ultra, the biggest, highest accuracy, but also you sacrifice some latency there. And Nano, something that you can actually run on your local machine. So I just wanted to pause on this slide really quickly because I was proud to see Crew AI right here, agent orchestration and management. And these are just the partners of NVIDIA. All right, the next thing, and by the way, he is far from done, so really stick around. Right now, he's going to tell us about their world model. This is a world foundation model that they are building. That is a model that can understand the physical world. And if you follow Dr. Jim Fan, who is a head researcher at NVIDIA, you probably already knew something like this was coming because they have projects like Groot and many others that allow the simulation of different environments, both physical and digital.
And so all of these types of understanding, is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create we need a world foundation model. Today, we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it. The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance. Even across multi-sensor views, Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
All right. So much just happened in that video. So first of all, anybody who doubted the simulation theory, the theory that we already live in a simulation, maybe you are slightly in more agreement now. So that is NVIDIA Cosmos. And here's a few ways to think about it. One, it is a world simulator. It is meant to simulate the physical real world, something that there are a few cutting edge models that are doing it right now. Sora might be considered one of them, but this is really hard stuff to create. And why do you need to simulate the real world? Well, besides the fact that it's just cool, all of our physical AI robots are going to need training data. And that training data, as the video said, is very hard and expensive to come by. So what if you just generate that physical data? What if you just generate the real world and then use that data to train the model? Now, a company like Tesla has millions of cars on the road, and each of those cars has a ton of cameras on them. So they are collecting real world, actual real world, physical data every day, all day. They are in a league of their own though. Most companies do not have that. In fact, the vast majority of companies do not have that. There's maybe only less than a handful that have that level of data. And I don't even know if they have anything close to Tesla. So what do you do? What do you do if you're a Mercedes? What do you do if you're a Figure Robotics? Well, you just generate the data. You don't actually need to solve the chicken and egg problem anymore. You don't have to have a bunch of robots out in the field to collect the data. You just generate it, and then you train your first generation of robots. So really amazing stuff. And of course, once again, what's powering all of this? NVIDIA GPUs. And one other cool thing that he said during that demo is multiverse generation. Basically, every single possible outcome can be generated by this model system. So really, it seems inevitable we're going to figure out we're in a simulation. Okay, so watch this part where he specifically talks about this.
In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios. Then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories.
All right, so that is just really cool. So he talks a lot about autonomous driving. Here are some of the partners that he's working with, and it's pretty much every single car company and every single autonomous vehicle company out there. And all of the stuff he's talking about with Omniverse also applies to autonomous driving, but it also applies to robots. Watch this.
I think the next part is robotics. So, humanoid robots, my friends, the ChatGPT moment for general robotics is just around the corner.
So, huge statement. The ChatGPT moment for humanoid robots is just around the corner. And that seems very accurate. All of these companies are working on humanoid robots, and the thing that has really unlocked their capabilities is the new wave of artificial intelligence. Look at all these robots. These are not made-up robots. These are all actual robots that are being developed by different companies. I see Optimus, I see the Figure robot, and many others.
And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars, and the reason for that is we spent 100 plus years building roads and cities. And then number 3, human or robots. If we have the technology to solve these 3, this will be the largest technology industry the world's ever seen.
So there it is. The robotics industry is going to be the biggest industry ever created, according to Jensen. Very, very exciting. All right, and now here's the one more thing moment. This is a supercomputer developed by NVIDIA for consumer use. Really cool. Let's watch.
DGX-1 really revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, and Ilya Sutskever was there, and many of NVIDIA engineers were there, and we celebrated the arrival of DGX-1, and obviously it revolutionized artificial intelligence and computing. But now artificial intelligence is everywhere. It's not just in researchers and startup labs. You know, we want artificial intelligence, as I mentioned in the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. Every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX-1 was smaller. And,
So cool. I'm sorry. I was giddy when I saw this. This is maybe the nerdiest thing ever, but I am just so excited about all of these cutting edge AI technologies, and it's so exciting to see the rate of development. Okay, I'm going to stop talking. Let's just watch what he's about to announce.
You know, imagine, ladies and gentlemen, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA's software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or connected to your computer. It's even a workstation if you like it to be, and you could access it. You could reach it like a cloud supercomputer, and NVIDIA's AI works on it.
Okay. So much just announced in those few sentences. This is a Mac Mini-esque supercomputer that can sit on your desk, sit in your closet. It is essentially a supercomputer for your home, local AI. And you know I love edge computing. So imagine this sitting in your home, powering all of your AI completely locally with an emphasis on privacy and security because everything's running open source and locally. This machine, which he's about to talk about, is going to run Linux and runs the full NVIDIA software stack. So you could do anything that you've done with any NVIDIA software to date right on this little machine.
And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside.
I think the design is gorgeous.
It's just so cute. And this is the chip that's inside. It is in production. This top secret chip we did in collaboration. The CPU, the Grace CPU, is built for NVIDIA, in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production.
All right, so look at this. 1 petaflop FP4 AI compute, 20 ARM cores, 128 gigabytes of low-power DDR5X memory. 128 gigabytes, that's pretty darn good. 4 terabytes SSD, which is the hard drive. It has Wi-Fi, Bluetooth, and USB, and so it's basically just a regular computer, but supercharged with these chips.
We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible what we could do. And it's just, I think it's, I was trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. You know, who doesn't want one of those?
So yeah, it seems like NVIDIA and Apple are kind of coming head to head. This is looking like the Mac Mini. It has the performance, or even better than a Mac Mini potentially. So this is very impressive.
Yeah, if you use PC, Mac, anything, because it's a cloud platform. It's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like. If you would like to have double digits, this is what it looks like, and you connect it together with ConnectX, and it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available, and so NVIDIA Project Digits.
So the one thing he didn't mention here, but is mentioned on the Digits website, is that a single one of these can run a 200 billion parameter model easily, and super impressive. So stack 2 of them together and you can run Llama 405B. Very, very cool. I think it's coming in around $2,000 or $2,500 if I remember correctly. And I'm going to try to get one. I already started stalking my NVIDIA contact to try to get me one. So I'm working on it. And so those are all the major announcements from the keynote. Very, very cool stuff. Now I'm off to see CES to get on the floor and see all of the cool AI stuff that's coming. I'm going to make a video about that as well. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.